Good morning, students. Now we are going to continue the same chapter. Same chapter means chapter number 3. Okay. In chapter number 3, now we are going to discuss the carbon register. Right? So in market, carbon registers are available in this type of shape. If you will open any electronic device, you will get this type of device inside the board, right? So there are 4 colors. So carbon register, it is made up of carbon material. There are 4 colors, color number 1, 2, 3 and 4. This color, right? This 4 color indicates the magnitude of this carbon register R. Okay? And how this color, how they identify the value of a register, let us see. So this color code having one pattern. Which pattern? BB Roy. BB Roy means B Roy. Name, consider one name. BB Roy goes to Bombay. Goes to Bombay. From where? Via Gateway. Okay? BBROY. BB Roy goes to Bombay via Gateway with gold and silver. Gold and silver. Okay? What do you mean by B? B means black, brown R, red O, orange, yellow, green, blue, violet, gray and white. Up to this you have to remember, that is BB Roy goes to Bombay via Gateway with gold and silver. Okay? What does it mean? That we will see later on. B R. Start numbering from 0, 1, 2. Then continue the number. You don't have to give number to gold and silver. Again, same numbering. Got it? Then you have to take, what to take? Power. Means here 10 raised to 0, 10 raised to 1, like this. Okay? And for this gold and silver, you have to take what? 5%, 10% and 20%. 20% for what? If there is no color. Got it? Okay. So here the first line give you first color, this line gives us second, it is third, and it is fourth. Got it? 1 2 3 4 4 color lines. 1 2 3 4 4 values. How you can measure the magnitude of any type of given register? Let us see. If there is a color orange, blue, yellow and gold, means in this type of register there are 4 colors. Suppose first color is yellow. So in first line you have to see where is yellow. Yellow is here. So take first 4. Take second line. If it is given orange, then orange. So this is second color. So you have to go for second line. Where is orange? Find out here. So 4 3 43. Okay, multiply by, now there will be a third color. If third color is, suppose it is again yellow, then 1 2 3 in third line, where is yellow? 10⁻3, that is 10⁻3. Okay, so this is the magnitude of this given register, given carbon register. Here see, fourth line is missing, right? Fourth color is not there. Then you have to see here, if there is no color, you have to put plus or minus 20%. What is this? It is nothing but tolerance. Tolerance, or in a simple language you can say it is error. Got it? So this is the value of carbon register, or you can write like this: 43 multiplied by 10⁻3, right? That you know what is 10⁻3? It is kilo. So you can write 43 kilo ohm plus or minus. There may be error of 20%. By this way you can find the value of carbon register. Isn't it? It is very easy. Just you have to remember that name BBROY, Roy, goes green color to Bombay via gateway with gold and silver. So for gold and silver you don't have to give number. Starting from 0, 1, 2, 2 times, third in the form of power. Clear? It is easy. Okay, now let us see second topic, that is electric energy. What is electric energy? First of all, let us see what is energy, right? From the secondary section, that means in 8 or 9 standard, there was a definition of energy. In 11th also, there was a definition of energy. What is energy? Energy is nothing but ability to do work by a body. But here we are taking charges. Okay, for that let us see, it is the second topic, that is electric energy and electric power. For this, we have to consider a conductor. Suppose this is a conductor. Consider 2 points A and B. Electric potential at point A is suppose VA and electric potential at point B is suppose VB. What is electric potential? That we have seen already. VB is greater than VA. It means B and is at higher potential, right? Then VA means VB, electric potential at a point B is more than electric potential at a point A, and because of this potential difference, electric current is flowing from higher potential to lower potential. That means A to B, or not A to B, B to A. Electric current is flowing. Okay, so simple. Let us consider a conductor. Consider two ends A and B. At A and B, electric potential is VA and VB. Electric potential at point B, VB, is more than electric potential at point A, VA. So, electric current will flow from higher potential to lower potential, A to B. So, this is the direction of flow of electric current. And flow of electric current is nothing but flow of electric charges. Clear? If electric charges are flowing, then what will happen? Then the potential energy of the charges are given by delta U. This is the potential energy. What is potential energy? That you know, energy associated with the position of a charges or particles. You can say that it is a potential energy, and that change in potential energy is given by final potential energy minus initial potential energy. Okay, final potential energy means you have to take the energy of a higher potential, that is potential energy. You know the equation, that is Q multiply by V. What is at a higher potential? VB minus again Q multiply by lower potential VA. Take Q common, so it is Q VB minus VA. Okay, what is VB minus VA? It is nothing but electric potential difference. What is Q? From the definition of electric current, I is equal to Q by T. From that, make a subject Q, write down, it is I multiply by T, and let us take VB minus VA is equal to, what is this? It is a electric potential, that is V. Okay, now you have to remember, if we are taking delta U, then you have to take delta Q. If there is delta Q, you have to take the definition I is equal to delta Q by delta T. So here there will be a delta and electric potential you have to take V. Okay, so it is a potential energy that having negative sign. Okay, so this is the energy when charges are steady, but when the charges are moving, it having kinetic energy, that is delta K, and you know that kinetic energy is equal to minus delta U. From where it comes? It comes from the law of conservation of energy. What was it? That is delta K plus delta U, that is total energy, becomes 0. That means change in kinetic energy and potential energy is mechanical energy, and mechanical energy is always constant. Constant means it do not change. Take on this side. Okay, so you will get the equation. Put the value of equation number 1, that is, it is minus, now minus minus plus, it is V multiply by I multiply by delta T. Okay, so this equation number 1 and 2 are the equations of energy, potential energy as well as kinetic energy. Have a look. Okay, so once again let us see. Take a conductor, two ends A and B, electric potential difference VB minus VA. Why? Because VB is more than VA. Okay, so point B is at higher potential, so electric current will flow from B to A. What about the potential energy of the charges? That means final, that means you have to take a point which is at a higher potential minus initial, that is low potential difference. Potential energy, it having equation U is equal to Q multiplied by V. So final means you have to take point B. Why? Because it is at a higher potential. Then simple. You have to take law of conservation of energy. Got it? From that you will get one more equation, that is of kinetic energy. Okay, now we will see about electric power. What is electric power? Right? Electric power is nothing but loss of energy. From where this loss came? Let us see. How? Let us see. When the electric charges are moving from B to A, then electric charges gain energy. Okay, and due to this, the kinetic energy increases. Means, let us see, when charges are moving from A to B, its kinetic energy increases. If kinetic energy increases, then obviously it gains energy. And this gained energy come out in the form of heat. Got it? And that is given by, means while while the charges are moving from A to B, it gain energy, therefore kinetic energy increases. This increases in kinetic energy come out in the form of heat, and you know that again heat is nothing but energy, that is delta W is equal to same kinetic energy, that is V multiplied by I multiplied by delta T. So now kinetic energy is converted into a heat loss, and it is given by delta W. Take delta T on this side. So delta W by delta T. What is this? Heat loss per unit time, which is known as electric power. And electric power is symbolized as capital P. And it is given by delta W by delta T. What remain? It is V multiplied by I. So this is the first equation of electric power. Okay? Then from Ohm's law. What is Ohm's law? Ohm's law. V is equal to IR. So replace V. You will get V is equal to IR and again I. So it is I square R. So it is form number 2. What is R? Resistance. Put the value of resistance, that is I square R. What is R? R is equal to V by I. One I will cancel out. Then you will get the same equation, that is, okay, give it equation number 1, the same. So there is a confirmation, okay, but if you will put the value of I from Ohm's law, you will get V multiplied by, what is I? It is the thing but V by R. Okay, so you will get third form is equal to V square by R. Give it equation number 3. So this equation 1, 2 and 3, they are the different form of electric power. Equation number 3 shows that, what it shows, that is P, electric power, is directly proportional to the square of the electric potential, but it is inversely proportional to R, resistance. Okay, what is the unit and dimension formula of power? Right, so power having unit W, that is joule, time, take it upside, so it is second inverse, and it was invented by one scientist, Watt, W-A-T-T, or simple you can put capital W. Okay, and it having dimension formula work, we have already prepared 122 minus, that is MLT, 122 minus upon time, that is T1, take it upside, so we will have a dimension formula M1 L1 T minus 3. Okay, so this is about electric power, its equation, its definition. What is electric power? The rate of heat loss, that is known as electric power. Its different forms, equation number 1, 2 and 3. Its unit watt and its dimension formula M1 L1 T minus 3.